In this section, we're going to learn a couple of different techniques that we can use to sketch polar graphs, the result of polar equations. So we often will see equations written in the form r equals some function of theta, and we wish to be able to sketch functions that look like this. So here I've got an example. We want to sketch r equals 8 cosine theta over theta is from 0 to 2 pi. So the first technique that we have for this is point-by-point plotting, just like we learned back when we were sketching lines or quadratic functions or other functions back in algebra. We started by maybe building a table and then plotting a bunch of points and then connecting the points in a way that made sense. So let's do that for the equation r equals 8 cosine theta. So what I'll do is I'll start by thinking of some thetas, and then I'll have r equals 8 cosine theta as the r value. So for example, if theta was 0, then r would equal 8 times the cosine of 0. The cosine of 0 is 1, so that's 8 times 1. That's 8. And then how about if theta was pi over 6? The cosine of pi over 6 is root 3 over 2, so that's 8 times root 3 over 2, so that's 4 times the square root of 3. Now, even on a basic calculator, we can calculate the square root of 3. It's about 1.732, so if we approximate this, 4 times 1.7, let's just say 1.73, that's 6.92. And then if it was pi over 4, right, that's our next nice angle, then I'd have 8 times the cosine of pi over 4 is root 2 over 2. And so that's 4 times the square root of 2. And so the square root of 2 is approximately 1.41. So 4 times 1.41 is 5.64. Pi over 3. So I'd have 8 times the cosine of pi over 3, 8 times 1/2. That's exactly 4. And pi over 2, the cosine of pi over 2 is 0. So that's 0. So let's see what we've got so far. Let's plot those points. Alright, so remember that we would write this point. Remember, when we write our points for polar coordinates, we write them as r theta. So this point would be 8, 0, 6.92 pi over 6, 5.64, approximately, I should say, pi over 4, and 4 pi over 3, and 0 pi over 2. So if we plot those points, let's see what we got here. Let's assume we have a scale of 1 on the axis, on the concentric circle. So 1, 2, 3, 4, 6, 7, 8 would be here. Right, there's that point 8, 0. 6.92 pi over 6. Here's the pi over 6 radius. And then 6.92 is about there. Oops, sorry about that. Alright, and then I've got 5.64 pi over 4. 5.64 is about here. And then 4 pi over 3. Here's the pi over 3 axis, and 4. And then 0 pi over 2. So remember now, if r equals 0, that means it's through the pole. Right? It's pointing at the pole. So now, if we connect those dots, if we sort of look at what's happening here, it looks like the radius is decreasing, right, from 8 to 0. The r value is decreasing from 8 to 0 as theta is changing. And if we connect those, it seems to suggest a circular pattern. It seems to suggest that we have a semicircle. And it's tough to draw with the tablet that I'm using here, but that. Okay, so that's what we've got so far. All right, so now we continue. We go to our next nice point. Our next nice point would be at 2 pi over 3. And now so for 2 pi over 3, now I'm in quadrant 2. The cosine is negative. So I'd have 8 times negative 1/2. That would be negative 4. All right, and then at 3 pi over 4, I'd have 8 times negative root 2 over 2. So that would be approximately negative 5.64. 5 pi over 6. I'd have 8 times negative root 3 over 2, which is approximately negative 6.92. And then at pi, the cosine is negative 1. And so that would be negative 8. All right, so now let's plot those points. Okay, and remembering that this means the point negative 4, 2 pi over 3. Negative 5.64. 3 pi over 4. Negative 6.92. 5 pi over 6. And negative 8 pi. Remember that a negative r value means that you flip or you walk backwards, however you want to think about it. So 2 pi over 3, here's the 2 pi over 3 radius, but if I need to walk 4 steps backwards, that would bring me 1, 2, 3, that would bring me to here. The 3 pi over 4, here's the 3 pi over 4 radius, but I need to walk negative 5.6 units in that direction. All right, and I got to walk backwards. 5 pi over 6. Here's the 5 pi over 6 radius. I need to walk backwards 6.92 steps. And then in the direction of pi, I need to walk backwards 8 steps, and that puts me back where I started. And it looks like I've completed a circle here. All right, well, what if we went to the next nice point? So the next nice point would have been at what, 7 pi over 6. At 7 pi over 6, the cosine is negative, so that would have been 8 times a negative root 3 over 2, which is again negative 6.92. So if I go at the direction of 7 pi over 6, which is here, if I go in the direction of 7 pi over 6 and I walk backwards 6.92 steps, that brings me to this point again. And so what I see is that it's repeating this cycle over and over and over. And so this graph in blue, this circular graph, is the graph of r equals 6 cosine theta. All right, so that's r equals 8 cosine theta. All right, that graph is the graph of 8 cosine theta. And so we can use a point-by-point plotting and then connecting to do this. So what I'd like for you to do is I'd like for you to try one of these on your own. Go point-by-point plotting and see if you can graph r equals 5 minus 5 sine theta. So now is a good time to pause to try this one out on your own. If you do this correctly, you get a nice shape. I'll leave it at that. All right, so I hope you took the time to pause and try this one out on your own. All right, so I'm going to start with the point-by-point plotting again. So, set up my theta and my r table here. So again, let's start at 0. The sine of 0 is 0, so I'd have 5 minus 5 times 0, that's 0. All right, now let's see. What if it was pi over 6? The sine of pi over 6 is a half, so that's 5 minus 5 times 1/2. That's going to be 2.5. Pi over 4, that's 5 minus 5 times root 2 over 2. square root of 2 over 2 times 5. I've got to do this one. Let's see. 5 minus 5 times square root of 2 over 2. It's 1.46. It's approximately 1.46. Pi over 3. 5 minus 5 times the sine of pi over 3 is root 3 over 2. So 5 minus 5 times root 3 over 2 is 0.67. And then at pi over 2, the sine is 1, so I'd have 5 minus 5 times 1, which is 0. All right, so let's plot what we have so far. No, I'm sorry. Back up here, it shouldn't have been 5 minus 5 times 0. That's 5 minus 0, which is 5. I made a mistake up here. Sorry about that. All right, so let's plot what we have so far. We have r equals 5 when theta is 0. So 1, 2, 3, 4, 5. Then at pi over 6, we have 1, 2.5. Then at pi over 4, we have 1.46. It's about here. Then at pi over 3, I'm at 0.67, so that's about here. And then I'm at the pole. So far, I have what looks like this shape. All right, so now let's continue. So that was the first quadrant. Now let's go to 2 pi over 3. That's our next nice angle. So the sine of 2 pi over 3 is positive root 3 over 2. So that's going to end up being a 0.67 again. And at pi over 4, 3 pi over 4, the sine is positive again, so that's going to be about 1.46. And at 5 pi over 6, the sine is still positive, so that's going to give me a 2.5. And then at pi, the sine is 0, so that's going to bring me back out to 5. All right, so plotting those points. At 2 pi over 3, I'm back out to 0.67, so that's about here. Sorry about that. And 3 pi over 4, I'm at 1.46. About here. At 5 pi over 6, I'm at 2.5. And at pi, I'm at 5. 1, 2, 3, 4, 5. It's out here. All right, so then I have this piece. Oh, I got some of those points were off a little bit. I was on the wrong radii. Let's try that again. At 2 pi over 3, that's this one. I'm at 0.67. That's about here. And then at 3 pi over 4, 1.46. That's here. And at 5 pi over 6, 2.5. That's here. All right, that's more like it. All right, so this, I haven't connected. I haven't gotten back to where I started like I did in the previous exercise. So let's continue. Let's do some more points and see what happens. All right, so my next nice point would be 7 pi over 6. At 7 pi over 6, the sign is negative, right? Because I'm in quadrant 3 now. So the sign is negative. So this would be 5 minus 5 times negative 1/2. So that's 5 plus 2.5. That's 7.5. So then similarly, at 5 pi over 4, this would end up being 5 plus 5 times root 2 over 2. And so then that is 8.54. And at 4 pi over 3, this would be 5 minus a negative again, so it would be 5 plus 5 times root 3 over 2, 9.33. And then at 3 pi over 2, the sign is negative 1, so this ends up being 5 plus 5, 10. Let's plot those points. So at 7 pi over 6, so that's on this axis, I'm out to 7.5. At 5 pi over 4, 8.54. At 4 pi over 3, 9.33. At 3 pi over 2, I'm at 10. And if we go and fill in the last few details, at 5 pi over 3, it again ends up being positive 9.33. At 4 pi, at 7 pi over 4, 8.54 again. At 11 pi over 6, this ends up being 7.5 again. And then at 2 pi, I'm back to 5. All right, so 5 pi over 3, 9.33. 7 pi over 4, 8.54. 11 pi over 6, 7.5. And connecting with a smooth curve, we get this shape, which sort of kind of looks like a heart. It's called a cardioid. So here's the graph of r equals 5 minus 5 sine theta. It's called a cardioid. And we get a shape like this whenever we have the graph of r equals some a minus a sine theta, or r equals some a minus a cosine theta. We get a shape that's similar to this. It might be a different rotation or a flip, but that same basic shape. Now, that was a long process. And so what I would suggest is there's a simpler way to do this, but we have to take a different approach to it. Okay, we have to take a different thought process. So what I'm going to do now is I'm going to do the same exercise, but I'm going to do it from a different point of view. So here's that same exercise. But what I'm going to do first is I'm going to graph the Cartesian graph. I'm going to graph thinking of the r as a y and thinking of the theta as an x. How would I sketch y equals 5 minus 5 sine x? We learned how to do this back in a previous chapter. And so if I think of this graph, it has amplitude 5, it has a vertical shift of 5, and it's the sine curve flipped over. The period's 2 pi. So let's put 2 pi out here. So then here's pi, pi over 2, and 3 pi over 2. Here's 5, and here's 10. Okay, so my midline, my important points, 0. Midline, midline, midline. Now, normally it would go to, normally the sine curve would go to a maximum first, but this is flipped, so it's going to go to a minimum first. So here's the curve. There's 5 minus 5 sine x. So now, if we notice, I've sort of turned the curve into 4 chunks, 4 pieces, right? 0 to pi over 2. what happens to the curve from 0 to pi over 2? The curve starts at 5 and decreases to 0. Now let's translate that over to polars. The radius starts at 5 and decreases to 0. The r value, but it's decreasing to 0 as the theta is changing, right? The theta is changing from 0 to pi over 2, and the r is changing from 5 to 0. I know it's got to start at 5 and go to 0, and the r value has to decrease, right? The distance has to decrease. Then what happens? From pi over 2 to pi, the r value has to change from 0 to 5. And it has, right, the r value has to increase from 0 to 5. Then, from pi to 3 pi over 2, the radius has to increase from 5 to 10. And then back, right, from 3 pi over 2 to 2 pi, the r value has to decrease from 10 back to 5. So we get a shape like that. And that's a lot quicker. Maybe not as precise, but if all we need is a rough sketch, this is much quicker to do than the point-by-point plotting. And so what I would recommend is that you try this technique instead of the point-by-point plotting, unless you absolutely have to do the point-by-point plotting. It just takes so long to do the point-by-point plotting. But if you can sketch if you know how to sketch this, right, the Cartesian graph, which you're supposed to know how to do from a previous chapter, if you can do this, then you can probably translate that to the polar graph by thinking in terms of the chunks, in terms of the pieces, and what's happening to the r value. Alright, so I'm going to stop this video, and in the next video we're just going to do more examples.